Hello everyone, in this video I'm going to show you the tuning I did on this Ryzen 5 8600G. So this CPU is notoriously made for integrated graphics performance. So this is a iGpu driven product, has a very nice integrated graphics. Therefore, the memory tuning is very important. And it's also notorious for having a very good memory controller compared to the average Ryzen CPU, which translates in very good frequencies and also lower latencies because it's a monolithic chip, no CCD, no IO die separation. So I've been running 10 hours of Y Cruncher here. Note that the Y Cruncher score here is a little bit different than what I would get when running the test alone without no other application running, but I decided to shoot the video this way, and so I'm getting for some reason a much higher score. I guess that's because it's running on a lower amount of RAM, but anyways, the average result I get when running alone is 7.20 bits per second here, and right now I'm having 8.35 for some reason. But let's stop Y Cruncher. Oh, and meanwhile you can see that I'm running at the thermal limit, and I'm currently running on this integrated like stock cooler here, and yeah, this results in about 85 watts limit for the CPU package, for the whole CPU. That is the maximum sustained load for this cooler at 85 degrees limit, I guess. I decided to keep this limit. I like it. I wouldn't go above 90 for sustained operation. Yeah, 10th testman 5 passed. OCCT CPU plus RAM passed. Pipe prime result. Y Cruncher is still here. Come on. Y Cruncher 5B result here. And Limpax, pretty regular score, very consistent. So I don't think I have any errors. And let's look at Zen timings. So I set FCLK, UCLK at the same value, which is a half of the memory clock, of course. And the memory is running at a very nice 8000 megatransfer. Since I like undervolting, I set the cache latency to 48, and the memory VDD is 132, while the VDDQ is 131. So these are minimized. I can go lower than this. And the biggest problem here of the setup is that I had to raise the CLDO VDDP to 1.6.16. And that was not expected. I didn't see anyone use that value. The stock value set by the motherboard is 1.5. Not 1.15. And it's very unusual to find a motherboard that sets a voltage that is too low for the proper operation of the system. So that's why it took me so long to actually find out that was the problem. And I actually found it out from a Buildzoid video that he made very recently. I was having I spent 2 weeks trying to figure out the problem for the system, and turned out it was the VDDP. And the interesting thing is that the VDDP, for some reason, probably doesn't have an error correction on that path. So that path doesn't have any kind of a mechanism for retransmission, for error checking, which means that it doesn't degrade performance before actually crashing. And it doesn't crash even it takes a long time to crash, even if I set it to 1.1, 1.08. I was having very apparent crashes at 1.07, but the 1.1 value that I set during the testing was stable for maybe 2 hours of Y Cruncher. And yeah, and in the end, to have 12 hours, 10 hours of operation, of course I test 24 hours in total, I had to set it to 1.16. And that was very unusual for me. you usually have like a much smaller gap between instability and like performance degradation and proper full stability. So that really took me 2 weeks to find out, and thanks Billzoid for figuring this out. What else? Other interesting things. The TWTRL at 32 is a trade-off in a way that if I set it that way, I get much better graphics scores. Not much better, but I get better graphics score. Here's times pi, for example, or I can run superposition. So graphics benchmarks would get better performance. Pi prime would get better performance, but Limpak would get slightly lower performance, and the same for VT3. So I set it to 32, while most people on the internet, I see them setting to 24. That might also be because I'm using a different kind of die. This is 32 gigabyte memory, so I'm using an older Hynix die, while maybe the new 24 gigabit ICs, 24 gigabyte sticks can run that at 24 easily. I have no idea, but that's what I set it to. If I set it to auto, it would go to 38, and again give me better Limpak and Y Cruncher, but lower graphics performance. TRFC 6096. Yeah, that's around the better trade-off between instability, between like consistency. It's the lowest value I can set where I have consistent scores for Limpak. So that means that if I lower it, I get slight instability. So that's it. Well, I can go to the BIOS. Well, I might run Geekbench first. I forgot I also did PC Mark. And another thing is that I, of course, lowered every single core to the minimum value. I will show that later in the BIOS. I used the what is that? Core cycler first as the first tool to find instability on the cores. And interesting enough, some cores were also unstable in a different way while using VT3. So I decided to run first core cycler as it's a lot less intensive on the system, so it doesn't stress that much. And that found me probably the single core instability, while VT3 found me some different instabilities on the multi-core test, on multi-core stress test. So the resulting curve offsets are like dictated by both core cycler and VT3 running for hours and hours. I run both. I run both for 24 hours stable. So that was a very long tuning session. Mostly actually because of the VDDP problem, but yeah, the core cyclers also took a good week of testing, because every time when you find an error with VT3 you have to restart. So, lucky enough, core cycler has a different mechanism. You might have known that, but whenever it finds an error, it just stops testing on that CPU or that core and keeps testing. So you can leave it going for hours and hours, and like can come back and find different CPUs that have had an error. And here we are with Geekbench done. So 2,800 for the single, 13,400 on the multi-core. So this is yesterday's result, which has a slightly higher single, a slightly lower multi-core, and this is the average. So we are getting about 10% better, 50% better single core, but a good 25% better multi-core score. So that's nice, a good improvement compared to the average results I get from Ryzen tunings, and it's even more impressive considering that I'm using the stock cooler. And yeah, I'm still getting 25% better multi-core. And now on another note, I set the BIOS. I flashed the BIOS to the B650M HDV M2, but I'm running the lower end B650M H2. The name is around here. Here it is. So this is a much cheaper, like 20 years cheaper board. It has a much worse VRM, but that really doesn't matter for this kind of machine anyways. So I ship it out, and the reason for this swap is that this motherboard doesn't have the tuning menus for single core, for per core curve offset. So I had to flash it manually using the USB stick and doing like recovery, like flash, like emergency flash procedure by renaming the BIOS in a USB stick and pressing the flashback button. Well, anyways, here's an overview of the settings here. So here's the dreaded VDDP. Here are some offsets in this area. The VDDR CPU domain, for some reason, was causing me performance regression for every value I set, so I decided to leave it alone, and everything else is supposedly minimized. The SoC is only 1.045, so it's very low. Yeah, the Infinity Fabric, I tried to set it to 2400, but that would get me much lower results for VT3 and Pi Prime, and only like I don't think it was even getting me improvements on other tests, so I decided to leave it at 2000, and I didn't try 2500 or above because I was getting instability at 2500, like at 2467. So these values are probably off limits. I think this is a very bad sample for this machine, for the CPU, because I've seen most people running at 2550, something like that on the Infinity Fabric, which might get me better results. But I'm also running on the stock cooler, so that's not really apple to apple. Most people posting on overclocking forums are gonna use a dedicated cooler. And so here's the AMD overclocking precision boost and the curve optimizer menu that is only unlocked if I flash it to the HDV BIOS. And these are the settings for each core, and these are all minimized after hours and hours and days of testing. What else? Yeah, the GPU has a 200 MHz boost clock override, positive, and yeah, you can see the result for this configuration in games on other videos. And here's the track count for the 3XS Dom Cigala's Cubase Pro Benchmark project, and we're toppling at 81 with their settings that are shown. Okay, let me show you this first. So we're at 32 samples, and yeah, here's the other settings. 64 beat float, normal, ASIO guard, and yeah, I'm playing 81 tracks. For some reason here, okay, here we are. Okay, yeah, of course when I move stuff around I get errors. I'm not used to this version of Cubase, which is the latest 14.40. I didn't try the 15 now. I don't think it's stable enough. Well, let's see if that was a problem with the interface or I was actually having problems. Okay, sorry. Let's do a full roll, 16 bars, but yeah, seems everything is like works perfectly fine at 80 tracks. So that's it, I guess. Let's show. Okay, as soon as I move the mouse, so I wouldn't say this is actually stable. As soon as I move the mouse, I get some playback errors, which is actually consistent with an experience from a friend that tried this machine before for audio, and he told me that the real-time performance was actually worst when filling the mouse and like using the machine. Even thought the raw power was similar to the 12400F, was the same. So that's why I actually dropped this as a machine for audio in the end. Let's check the power consumption during the playback. So we're pulling about 70 watts, apparently. Well, I guess that's it for the video. I showed you everything that you needed to know.